Chapter 8 is all about trigonometry. It begins by revising some Stage 5 concepts, and where the focus is on right-angled triangles, and in particular finding the lengths of sides or the size of an angle within a right-angled triangle. It then goes on to look at triangles that are not right-angled. So we can use trigonometry, in particular the sine rule and the cosine rule, which are different to the sine ratio and the cosine ratio. And we can use those rules, which you'll see later, and you may have already seen them in Stage 5. We'll use those to find, again, lengths of sides and sizes of angles, but in the latter case, the triangles will not be right-angled. We'll also look at finding the area of a triangle. We'll revise a little bit of geometry because that comes into some solutions. And we'll look at bearings. So looking at our compass, north, south, east and west. So biggest focus for this chapter is the concept of trigonometry. Trigonometry allows us, as you can see from this, it allows us to create an equation. Anything with an equal sign in it is an equation. And we know that once we have an equation, we can solve that equation. So our algebra skills are going to be important as well throughout this chapter. In 801, clearly we're looking at right-angle triangle trigonometry. So make sure you note that the triangles must be right-angle triangles. You can see here in these couple of examples, the triangles are right-angled. Now it's going to become really important that you observe that, because remember I said later in the chapter, we're going to look at triangles that are not right-angled. And we'll be using a different rule or trigonometry equation. So a different trig equation. So I've separated this first example into finding sides, and you'll see two, or you can see just here at the bottom, we'll be finding an angle. The process is almost the same. There's one slight difference. So if you can remember these 4 steps, that will really help. So if we're finding a side, now clearly in this question, the x, the unknown, the thing we're going to solve for, once we've got an equation, is here on this side of the triangle. So we're finding this green side. Over here in this example, the pronumeral here is on P, but that P represents the length of this side of a triangle. So clearly, these 2 examples are examples where we'll be finding a side. This little 4-step process, if you can learn that, like I said, that will make getting the correct answer so much easier. So step 1 says, identify the sides with respect to the angle. So within this triangle, you can see we've got this angle. So with respect to the angle, we hopefully know that the sides will either be opposite, adjacent, or the hypotenuse. One of those 3, opposite, adjacent, or hypotenuse. The hypotenuse never changes. It's always the angle opposite the right angle. So yes, you can see here we've got 14 on the hypotenuse, but then we need to identify the side. The other side is this x. So only identify the sides that have either got a pronumeral or a number on them. So we don't identify this side down here because it's not involved in this question. But the x with respect to the angle would be the opposite side. Now, what does that do? We've identified them, opposite and hypotenuse. It allows us to go on to step 2, which is choose the correct trig ratio. Opposite and hypotenuse is involved here. It's the only time, because over here we've got adjacent and hypotenuse, and here we've got opposite and adjacent. The only time opposite and hypotenuse is involved is when we've got the sine ratio. So already at this stage I could be writing, we want the sine of theta is equal to opposite over hypotenuse, and you can abbreviate it to that. So that, you can see, is going to create us an equation. This is where now our solution turns into algebraic processes. To complete that algebraic process, we need to move on to step 3, which is to substitute values. Do we, sine is our sine. Theta, do we know our theta? Yes, we do. It's 36 degrees 22 minutes is equal to our opposite side has an x on it and our hypotenuse has 14. Now, there is an equation. We saw that sine 3622 is a number stored on the calculator. So I've got a number sitting here, and you could go to your calculator and put the number in. I'll do one example where I do that with you. When you go to your calculator, it's really important that your calculator has a little D in the screen here, indicating that the angle you're measuring it in degrees. So if you don't see a D there, then please know that you press second function, and which accesses setup. We want to have it in the correct setup. 3 is what we want. This is DEG, represents degrees. So we press 3, and you can see that's how you change. If there is an R in your, or a G appearing in that spot, then please change it to a D. So we can see that the sine of 36 now, degrees, minutes and seconds we access using this DMS. Degrees, 22 minutes, we can actually close the bracket off there, is equal to 0.5929, etc. I'm going to write that number in. So you can see I've put that number in. The disadvantage, I guess, is that you could make a mistake transcribing from the calculator to this number. And it is a lot of digits. I guess as long as you just keep that on your screen, your calculator screen, that will be fine. Now, thinking about this algebraically, we've got x divided by 14. We want to get the x by itself. You probably know that you're going to multiply by 14. So multiply this side by 14. Back to the calculator, we want that answer multiplied by 14. And we can see it's 8.3. And you could fill in the rest of the decimal places and round it. And because there was no instruction about how to round, we can decide how to round, and I'm rounding to 1 dp, but I do that and indicate that that's what I've done. Here in the next example, I'll show you a slight variation at this stage here. But for the beginning, we'll follow these same steps. So these steps won't change. The only change will be in the algebra. So what we know here is that with respect to the angle, which is up in there, this becomes the opposite side. And with respect to that angle, here is the adjacent side. Now, opposite and adjacent appear here, which enables us to set up an equation that we've got an equal sign in it. We've got an equation opposite over adjacent. And in this case, the angle is 20.6 degrees. So we won't be using degrees, minutes and seconds. You'll see me use the calculator in a moment. Slight variation to the way we put our angle in there. The opposite side this time is 34 and the adjacent side is P. Now, this is a little bit different The p is in the denominator. We know algebraically that requires 2 steps. We may multiply both sides by p, which is good, but that creates p times tan 20.6 degrees. Now we know to get the p by itself, then we'd have to divide by tan of 20.6. So this 34 is divided by tan of 20.6. Note that I'm not putting the value for 20.6 into the question because I know it's just a number. Just like over here the sine of that angle was a number, this is a number. And I can divide. I know I would be dividing by that number to get the p by itself. And now we want 34 divided by tan 20.6, which you can use your fraction button to get your nice fraction up. 34 was all that's left, and it's over the tan of, and this time we're going to just put our angle in as a decimal, 20, whoops, no, I didn't mean that. That's better. And equals 90.4555. And again, show the calculator answer with the decimal places, and again, since there was no indication about rounding, we can decide how to round. I'm going to stop this video there and talk about finding an angle in a separate video.